Hey everybody, this is 11.1 Trig Ratios. So this whole unit is about trigonometry. Trigonometry comes from the Greek word meaning triangle measurement. So tri is in three, trigon is like three-sided, and then metry is measure. So we're just measuring triangles. We can measure sides, we can measure angles. And we're going to start today with just talking about what's called trig ratios. So trig ratios is just a ratio of two sides of a triangle. So triangles have three sides, so just think of the different ways you could set up ratios, fractions, okay? And we're going to talk more about that as we go along. When we talk about trigonometry, we're doing right triangle trigonometry, which means that all of our triangles are going to have right triangles. One of our angles is going to be 90. Okay. All right. So just a little bit of vocab is when we do these problems, we will always have what's called a reference angle. And typically we'll use the symbol or the letter, Greek letter, theta. All right. So usually either we're gonna use that to be able to solve, or we'll need to find that sometimes, and that will just vary depending on what type of problem we're trying to do. All right. We also want to be able to label the sides of the triangle, so whether they be hypotenuse, opposite, or adjacent. You're probably familiar with hypotenuse when you did like the Pythagorean theorem. All right, so the hypotenuse is always the longest side. It's always across from that 90 degrees. So this would be our hypotenuse. Next we have is the opposite side. So the opposite side is the side that is opposite of that reference angle. So this would be our opposite. It's opposite of that reference angle. And then the last thing is the adjacent side. So adjacent meaning next to. So this would be the adjacent. All right, you'll need to be able to identify that for any type of problem. So here are some examples where I'm going to ask you to label the sides. Label the sides as either hypotenuse, opposite, or adjacent. I always like to start with the hypotenuse. Again, it's always across from that 90 degrees. Oops, that's not what I meant to write down. I meant to do H. So we can just abbreviate it for H. Opposite, again, is opposite of that angle, so this is our opposite, and then this would be our adjacent. So we end up getting HOA. If you ever ran into an HOA, or maybe you live in a place that has HOA, maybe that can help you remember. So again, I always start with my hypotenuse. Why don't you pause and maybe do these two? Hypotenuse, opposite, and adjacent. Hypotenuse, opposite, adjacent. Okay? And we're going to need that, so make sure you are strong with that. If you have questions, please let me know. Number 2, so this is just kind of comparing the reference angles. If the reference angle is A, our hypotenuse here would be C, our opposite side would be A, and the adjacent would be B. But if the reference angle was angle B, so I'm marking that over here for B, we would still have the same hypotenuse. So the hypotenuse is always the same. But here, with the blue where I wrote down the reference angle for B, opposite here would be B, and adjacent would be A. So it's important that you realize that you can't just randomly choose which is the opposite and adjacent. It matters depending on what the reference angle is. All right, so now we're going to get into trig functions. So just like any other function, maybe we've had an equation that would be like y equals 2x squared plus 5. If you had an x and you needed to find a y, we could plug it in and it would give us what y is. But sometimes we wrote this in function notation. That was like f of x equals blah, 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 blah. So again, it's just telling us what our input is. Our input here is x, all right, and then it would give us our answer, our function, our solution, okay? It's kind of the same thing when we talk about trig functions. So here we have these three trig functions. All right, we have sine, spelled S-I-N-E. We have cosine, and then we have tangent. Okay. And again, just like when we did our f of x here at the top, it's not f times x. We're evaluating the function when x is whatever number we want. Okay, it's the same sort of thing with sine. It's not sine times theta. We're evaluating the sine function when theta equals some number, some degree, maybe 45 degrees or 100 degrees. Okay. And these functions, they relate, just like here we related the x with the y, the sine of theta is related to two of the sides of the triangles. Okay, so for sine, it's always going to be opposite over hypotenuse. So if you know what the opposite side is and the hypotenuse side is, then you could figure out what theta is, because there's a direct correlation between those two. Okay, the relationship between the angle and its ratio. All right, so that works for those two sides, but for cosine it's going to be adjacent over hypotenuse. So basically we're writing down all the different combinations of the sides of a triangle. And then tangent is opposite over adjacent. All right, so if you're given any of the two sides of a triangle, then you would be able to come up with any of these ratios. One of the ratios, I guess I should say. All right, you're going to need to have these memorized in order to do some of these problems. A good way to remember is SO, CA, TOA. This is sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse, and then tangent of theta is equal to opposite over adjacent. So, CA, TOA. You'd probably want to maybe try and memorize that if you can. SOHCAHTOA. All right, I wrote it here again on the next page to help us when we do some of these problems. I wrote it a little different, but same sort of thing. Sine of theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Okay, again, it's just that relationship between the angles and its sides. All right, so what you're going to be asked to do is to write down the trig ratio for a specific trig function. So for tangent, again, we could go over here. Tangent is opposite over adjacent. So what we're looking for is that ratio, opposite over adjacent. So to be able to figure that out, we'd probably want to label our sides. We have our reference angle. We know that this is going to be our hypotenuse. It's opposite of that right angle. This is our opposite, and this is our adjacent. So what we're looking for is opposite, which is 12, over adjacent, which is 16. And then we just want to simplify our fractions. So we can divide everything by 4, and we're going to get 3 over 4. And that's your answer. That's basically it. We're going to add a couple things that you've already done before in order to simplify further. Here's another example where we have cosine of z, and z is this vertex, and its angle is z. Okay, so that's our reference angle, meaning that this is our H, O, and A. So now we can write down our ratio. So cosine, go up here. Cosine is adjacent over hypotenuse, and adjacent is 21, and hypotenuse is 35. Simplify, looks like we could divide top and bottom by 7, so we get 3/5. Alright, so you might run into something where a side has like a root. If you can't see it, it's the square root of 3. This is 16 and 8. Alright, so we want to find sine of theta. What's that ratio? Again, maybe we'll start with labeling our sides. This would be hypotenuse, opposite, and adjacent. And sine is opposite over hypotenuse. So again, we look at SOHCAHTOA up here, it's opposite over hypotenuse. So we'd have O, which is 8 square roots of 3, over H, which is 16. Again, when we simplify fractions, we only want to simplify things that are outside of a root. Okay, so that would give us 1/2. So 1 square roots of 3 over 2. Or you could also see it like the square root of 3 over 2. Okay? All right. Oops, I guess I did not delete these. Let me do those real quick. Oh, man. Hang on, sorry, one sec. I guess you could just pause and write all that down, but okay. Okay, so let's keep going. All right, so next one, what do you notice that's maybe a little different is that one of the sides is missing. And you've learned how to do that if you have 2 of the 3 sides, is we could use the Pythagorean theorem. That's a squared plus b squared equals c squared. And what's important is that you realize is that the c has to always be your hypotenuse. So I'll give you an example, 2 examples to help you remember. So here they want to find, well, maybe we'll label our sides first. So here's our hypotenuse, opposite, and adjacent, and they want us to find sine of theta. And that's our SO for SOHCAHTOA, O, so O over H. We have our O, but we don't know our H, so we could do 4 over something. But we're going to need to find what H is, so we'll use the Pythagorean theorem. Again, if you prefer, you could do, this could be A, this could be B, this could be C. You could use H, O, and A, HOA, it doesn't really matter. So here we've got 3 squared plus 4 squared equals H squared. And again, the hypotenuse always has to be on the right side. So here we'd get, what, 9 plus 16, which is 25, is equal to H squared. And if we want to get H by itself, we need to get rid of that squared. So we'll square root, and we'd get H equals 5. So H equals 5, and now we can put that in our ratio, and we're good to go. So over H, 4 over 5. So that's where we had our legs of our triangles were given, and we needed to find the hypotenuse. Sometimes you'll have something like this, where you have the hypotenuse and one of the legs. But it's the same sort of thing. You just need to realize that this is your hypotenuse, and that needs to be on the side by itself. This would be our opposite, this would be our adjacent. So we'd do something like a squared plus b squared, or o squared, which is 6 squared, equals 10 squared. So that's 36 equals 100. And then we want to get a by itself. So 36, get a squared equals 64. And then we'd square root both sides and we'd get a, our adjacent side, is equal to 8. So then we could write down our ratio. So SOHCAHTOA, OA, and then O is 6 and A is 8, and we just simplify it 3/4. Okay, so there's just 2 examples. Those are the 2 types that you could run into, is maybe the hypotenuse is missing or maybe one of the legs is missing. All right. Okay. So again, you've done the Pythagorean theorem before, and then here we've also covered this before too, rationalizing the denominator. So a fraction is not fully simplified if there is a radical in the denominator or in the bottom. Okay? If you remember how we do that, to rationalize it is we just multiply top and bottom by that square root. And then when we multiply fractions, we multiply straight across. So that's just the square root of 3, because 1 times the square root of 3 is just the square root of 3. And then the square root of 3 times the square root of 3 we can multiply those because they're both in square roots. That would give us the square root of 9, and that gives us 3. Okay, if you wanted to have that 1 out in the front, that's fine. Okay, but that's how we rationalize the denominator. Let's look at C. Same sort of thing. We only need to multiply top and bottom by the square root of 6. So we'd get 3 square roots of 6. Again, these are not the same. They're not both in a root, and they're not both out of a root. So we can't do the square root of 18. That would be not good. Okay, but these two are both in a square root, so that's the square root of 36, or 6. But we still have this 2 already, so we've got 2 times 6. So that's 3 square roots of 6 over 12. And then again, we only simplify what's outside of the root. So that would be the same as 1/4. So we could divide top and bottom by 3. All right. So here's the type of problem that you would run into. So we'll just look at H today. They want us to find the tangent of theta. And again, that's our SOHCAHTOA. So we need opposite over adjacent. Here's our hypotenuse, here's our opposite, here's our adjacent. So we have all the information. We don't need to use the Pythagorean theorem. But here we'd have opposite, which is 5 over 4 square roots of 6. So here we have a root in the denominator. We need to rationalize it, so we'd multiply top and bottom by the square root of 6. So 5 square roots of 6 over 4 times, and again, this is just the square root of 36, or 6. So 5 square roots of 6 over 24. And that can't be simplified. You can't, the only thing that goes into 5 is 5 and 1, and the only thing that, and 5 doesn't go into 24. So that's the type of problem. And then you also maybe run into one that's like this, where you do need to use the Pythagorean theorem. Here's our opposite. I guess I'll write hypotenuse, opposite, and adjacent. And sine is O over H. So we're missing H. So here we would need to use the Pythagorean theorem. So we could do 10 squared plus 15 squared equals H squared. That's 100 plus, I always forget this one, 225 I think. How about if I turn it on? 225. So we get 325 equals H squared. And then we'd need to square root both sides. So if you notice, if you try to square root, it will give you a decimal that has no pattern, never ends. So if this is the case, then you would want to simplify the root. And if you remember, we did that with a factor tree. So here we could take out, I know that 5 goes into it. So I'd take my calculator and I'd do 325 divided by 5. It gives me 65, and I think 5 goes into it again. And that gives you 13. 13's prime. So here we have a group of 5s. Again, that comes out, and what's not in the group stays inside. So that's what H should be, at least if you want to have it simplified. Okay, so now we can write down our ratio. It's O over H, which is 15 over 5 square roots of 13. And then we can simplify this. That gives you 3 over the square root of 13. Sorry. And then we just rationalize it. So 3 square roots of 13 over 13. All right. So that's probably the hardest that can get, is maybe you need to rationalize it. Maybe you need to simplify the root. Okay. And then the last thing that you're going to run into, and maybe something like this on the test, is something like this. They want us to find the ratio for sine of theta. Well, that's O over H. If tangent of theta is equal to, that's an equal sign, equal to 3/4. We know that tangent is TOA, that's opposite over adjacent. So basically we know what O and we know what A is. The best way to do this, I think, is to start by sketching the situation. Here's my reference angle. This would be my hypotenuse, opposite, and adjacent. And they give us the O and the A. So that's 3, and this would be 4. If we need sine, then we just need to figure out what H is. We already know what O is. O is 3. We just need to figure out what H is. So this is a special type of triangle, and we'll figure that out, I think, as we go along. But we'll start with the Pythagorean theorem. So a squared, so that's, I guess maybe I'll do a as a. So 4 squared plus 3 squared is equal to h squared. That's 16 plus 9, which is 25. And then we would square root both sides. So now we find out that h is 5, and now we know our ratio is O over h, which is 3 over 5. Okay? So that's it. Start with sketching what's going on. This is the kind of a special triangle, 3, 4, 5 triangle. If you notice that as you go along, that might save you a little bit. You might not need to use the Pythagorean theorem. But, so like here for cosine, just in case you wanted to give this one a try, that's so ca a over h. So again, this would be our a, this would be our h, but we need to figure out what O over h is. So we need to figure out what O is. Alright, well, if you have any questions, let me know. We'll see you later.